So hello everyone. Let's talk about how Hotstar handled 13 million concurrent users during the recent India versus Pakistan Asia Cup 2022 match, and 13 million is like 1.3 crores. So you can imagine कितना बड़ा number है 13 million. So here are some previous records by Hotstar. कुछ जो पहले के records है concurrency में. So there was 8 million concurrent users. First of all, let's talk about this term concurrent users. किस किस को नहीं पता concurrent users क्या है? Just speak up. अगर जिसको नहीं पता, आई अज्यूम सबको पता है. concurrent users like basically एक साथ जितने लोग जो देख रहे हैं. That's it. अगर 1.3 crores people are watching the match currently on Hotstar platform, so that's like concurrent users. So उससे पहले there was this record by YouTube that they handled 8 million concurrent users. Then NBC Sports app ने 3.1 million का रिकॉर्ड था, even though YouTube को बीट नहीं कर पाए, but that's fine. Then during IPL 2018, Hotstar made a record of 10.3 million concurrent users. Then 2019 they broke their own record with 18.6 million users. And then in World Cup, India versus New Zealand, they broke again their previous record with 25.3 million concurrent users. This time they had like 13 million users, so no new record, but still 13 million concurrent users is still a big achievement. So let's talk about how they did it. We'll start with the concurrency pattern, जहाँ पे हम देखेंगे कि कैसे यूज़र concurrency बढ़ती घटती है. लाइक कई बार कितनी जल्दी यूजर्स ऐड होते हैं सिस्टम में और कितनी जल्दी ड्रॉप हो जाते हैं सिस्टम में. एंड देन सिस्टम हैज़ टू स्केल बेस्ड ऑन द अमाउंट ऑफ यूजर्स दैट आर इन द सिस्टम. देन विल टॉक अबाउट इन वेरी माइनर अबाउट इंफ्रास्ट्रक्चर की हॉटस्टार क्या इंफ्रास्ट्रक्चर के लिए यूज़ करते हैं. देन विल सी इन टेस्ट देयर सिस्टम बेसिकली क्या क्या चीज़ें वो टेस्टिंग के लिए यूज़ करते हैं टू मेक श्योर दैट देयर प्लेटफॉर्म इज़ लाइक बैटल टेस्टेड, वो एक्चुअली हैंडल कर लेगा उतना लोड. एंड देन लास्टली विल टॉक अबाउट हाउ डू दे एक्चुअली स्केल, क्या क्या टेक्निक्स यूज़ करते हैं वो लोग टू स्केल देयर इंफ्रास्ट्रक्चर. सो बिफोर आई स्टार्ट विद द कंकरेंसी पैटर्न, एनी क्वेश्चन सो फार? नो, ऑल गुड. ओके, लेट्स टॉक अबाउट कंकरेंसी पैटर्न. बाय द वे मैच काफ़ी अच्छा था, जिसने मिस कर दिया आई डोंट नो, बट मैच काफ़ी इंटरेस्टिंग था. ऑलराइट, लेट्स ड्रॉ दिस ग्राफ. ओके, सो एक्स एक्सिस पर है टाइम and then y-axis पर है number of users, and number of users actually millions में है. So y-axis पे will draw कितने million users हैं, और x-axis पे will see time, like जैसे अगर एक मैच की जो ड्यूरेशन है whatever 5 or 6 आवर्स जितनी भी है, उस ड्यूरेशन में कैसे कैसे number of users सिस्टम में बढ़ते हैं या घटते हैं. So let's start from here. तो इनिशियली जब मैच स्टार्ट होता है तो धीरे धीरे लोग लाइक लेट्स अज्यूम बहुत कम करेंसी है, अ फ्यू लेस देन अ मिलियन, लेट्स से लेस देन 1 मिलियन हियर. यहाँ से लोग ज्वाइन करना स्टार्ट करते हैं जैसे मैच स्टार्ट हुआ. तो आई गेस स्टार्टिंग में टॉस होता है तो दिल स्टार्ट समवेयर हियर. बहुत ज़्यादा लोग ज्वाइन नहीं करते टॉस के दौरान, बट लेट्स से इट्स समवेयर हियर 3 to 4 मिलियन. देन टॉस होने के बाद थोड़ा सा ड्रॉप आएगा बिकॉज देन टॉस फिनिश हो गया, और उसके बाद फिर बैटिंग स्टार्ट होगी. तो जब फर्स्ट टीम बैट करती है, इधर इट्स XYZ टीम और वट एवर, लेट्स से इस बार पाकिस्तान ने बैटिंग स्टार्ट की थी, तो देन नंबर ऑफ यूजर्स विल इंक्रीज इमीडिएटली क्योंकि मैच स्टार्ट हो गया. एकदम से यहाँ पहुँच जाओगे आप. नाउ आई एम नॉट यूजिंग एक्चुअल नंबर्स कि कितने यूजर्स है. लेट्स से समवेयर हियर इज 13 मिलियन एंड एनीथिंग इन बिटवीन 0 to 13 मिलियन. सो लेट्स से पाकिस्तान ने बैटिंग की, देन यहाँ कुछ टाइम तक ऐसे रहा जब तक पाकिस्तान ने बैटिंग की. एंड देन जैसे ही बैटिंग फिनिश हुई तो ब्रेक आता है, जब दूसरी टीम यानी लेट्स से इंडिया टीम जब अपना जाके वो सब करते हैं कि अपनी बैटिंग के लिए प्रिपेयर करते हैं, तो देयर इज़ अ ड्रॉप बिकॉज उस टाइम पे एड्स वगैरह और फिर कमेंटेटरी रहती है सिर्फ, लेकिन स्टिल मैनी पीपल वेट. तो लेट्स से कंकरेंसी यहाँ से यहाँ ड्रॉप हो गई, एंड देन कुछ टाइम बाद इंडिया की बैटिंग स्टार्ट हुई तो अगेन फिर से जंप आता है कंकरेंसी में. एंड देन लेट्स से वो कुछ ऐसे चला, एंड देन लेट्स से कि कोई प्लेयर बहुत अच्छा खेल रहा है, एंड लेट्स से धोनी खेल रहा है, एंड धोनी ने 3-4 छक्के मार दिए, 3-4-6 मार दिए. देन व्हाट दे विल डू इज दे जनरली सेंड दिस नोटिफिकेशन और समथिंग लाइक दैट कि धोनी बहुत अच्छा खेल रहा है, वी आर अबाउट टू विन द मैच, और अदर वे ऑल्सो लाइक वी आर अबाउट टू लूज द मैच और समथिंग. बट लेट्स थिंक पॉजिटिव, लेट्स से कि ऐसा सिनेरियो बनाया कि वी आर जस्ट अबाउट टू विन द मैच, सब लोग आके देखो, तो उस नोटिफिकेशन सेंड करने के बाद लॉट्स ऑफ पीपल आर एडेड इनटू द सिस्टम, तो कंकरेंसी एग्जाम से फिर से जंप कर सकती है, एंड लेट्स से लाइक दिस इज द 13 मिलियन मार्क फॉर नाउ, एंड देन यू रीच योर पीक कंकरेंसी, एंड देन यू आर अबाउट टू, उसके बाद इधर यू विन और लूज वट एवर, बट जैसे मैच खत्म हुआ कंकरेंसी फिर से नॉर्मल लेवल्स पे ड्रॉप कर जाएगी एकदम से, लाइक बहुत ड्रास्टिकली ड्रॉप करते हैं, बिकॉज जैसे ही मैच खत्म हुआ पीपल जस्ट, कुछ लोग अभी भी रुकते हैं प्लेटफॉर्म पे, बट मोस्ट ऑफ देम जस्ट लीव, बिकॉज उनको कुछ और काम करना होता है जो अटका हुआ है और वट एवर, देन दे लीव फ्रॉम द प्लेटफॉर्म, तो बहुत जल्दी कंकरेंसी नीचे आ जाती है. सो दिस इज लाइक, दिस इज नॉट एग्जैक्ट रेप्लिका ऑफ व्हाट हैपेंड, बट दिस इज हाउ द पैटर्न लाइक गोस एकदम से. द पॉइंट टू और द की टेक अवे हियर इज कि एकदम से कंकरेंसी बहुत जल्दी बढ़ती है और बहुत जल्दी घटती है. सिस्टम में ऐसे होता है, पीक बहुत जल्दी आ जाती है और बहुत जल्दी नीचे भी चले जाते हैं, तो यू हैव टू हैंडल, दिस इज द डेंजर जोन. हाउ डू यू गो फ्रॉम हियर टू हियर, हाउ डू यू स्केल योर सिस्टम. एक बार यहाँ पहुँच गए तो मेंटेन करना इज मच ईजियर, बट इंक्रीज और डिक्रीज करना इज वेयर सिस्टम्स जनरली ब्रेक. लाइक इंक्रीज करना है कि सबको समझ आ रहा होगा, बट डिक्रीज करने में भी इट हैपन्स. आई टॉक अबाउट व्हाई. So yeah, that was concurrency pattern. Let's talk about the actual infrastructure now. तो concurrency pattern में किसी को कोई question? No, all good? Okay. प्लीज़ लोग चैट में भी देखते रहना, बिकॉज आई एम नॉट लुकिंग एट चैट. अगर किसी का कोई क्वेश्चन है तो जस्ट पिक अप, I'll answer that. Let's move on to the infrastructure part. Let's say, let me give my some space. So infrastructure में I'll just very in briefly talk about what they say that they are using. So they use AWS for all their basically compute or storage or basically servers. So AWS, सबको पता है AWS क्या है? Amazon Web Services. कोई है जिसको AWS नहीं पता? सबको पता है. And then they use service for CDN, ACMI or whatever it is called for CDN. अब CDN है, कोई है जिसको CDN नहीं पता क्या होता है? Content Delivery Network. सबने टर्म सुनी है CDN? नहीं पता तो just speak up, I'll try to explain. Cool. Assuming सबको CDN पता है, तो this is what they use for CDN, and those are the main two set of infrastructure that they have, और इसी में सारी चीज़ें उनके सर्वर्स वगैरह रहते हैं. Now let's talk about the main thing. Actually, second main thing. How do they test basically? How do they make sure कि जब actual चीज़ होगी, जब actual match होगा, तो their system will be able to handle the concurrency. How do they make sure beforehand? How do they test their system? So let me get some space. So this is where they do these performance testing, basically performance testing. And first thing is they need to generate the load. Like उन्हें simulate करना पड़ेगा. If actually में 13 million users थे, then let's say they want to simulate 4 or 5 million users. उतने users simulate करने के लिए they need to generate that load somehow from machines like bots के through. So that's first part, load generation. Then जब load generate हो गया तो then this send this load to their system. That's where they test the their performance. So that's performance testing. And then there is also third thing called chaos testing or engineering, whatever you call it, chaos engineering. Let's talk about this load generation first, and then we will talk about chaos generation or chaos engineering. So performance testing मैंने बताया, like this is the term. How your system performs under certain load, that you test your system for performance. Load generation, how they actually generated the load is they had these bulky machines. Like I'll use actual numbers जो मुझे Hotstar team से पता है, engineering team से I am using their actual numbers. They use these machines, 3,000 machines basically, or EC2 instance. अगर Amazon, so EC2 is like their instance name in AWS. What they call, this is what you use for servers, and they use 3,000 machines or EC2 instances, and each of them had 36 CPUs and 72 GB of RAM. So अगर तुम इसको मल्टीप्लाई करोगे 3,000 और 3,000 into this much capacity, so you'll get what, one, I don't know, it is like 10, these many cores or CPU cores basically, and if you multiply 72 with this, then you get this much RAM, I guess. at this much RAM, which is effectively 216 TB of RAM. This is the amount of infrastructure they used just to test their system, just to generate the load for their system. And this is huge. Like, you can already see the numbers. This is very huge. And let me also use some other numbers. They also used like इतना load generate करने के बाद they had this much amount of network bandwidth, 200 GB per second network out basically, or bandwidth going out of the system, because वो stream कर रहे थे इतना सारा videos and all of their data. So this much was the bandwidth, and they distributed the load, because Hotstar ऐसा नहीं सिर्फ इंडिया में है. Hotstar is in, even like, as far as I know, they are in more than 40 countries. So what they needed to kind of distribute this load, and वहाँ से टेस्ट करना था उन्हें. तो they distributed the load in 8 regions which are like geo distributed, and that's how they basically generated all the load for their performance testing. Now let's talk about the chaos engineering part. This is very interesting, like what kind of things, like what are the strategies basically they used to test. Like इतना load, ये तो actually node generation का number, but ये load कहाँ से आ सकता है, वो part let's talk about in chaos testing. अब किस को पता है, like I don't know, maybe शायद सबको नहीं पता होगा, बट किस को पता है chaos testing का? Can anybody explain in like 1 or 2 lines, या फिर जैसे भी उसको सूट करता है, what is chaos testing, if somebody know? किसको नहीं पता chaos testing? That's fine. Alright then. So let's see the word first, chaos, or you can write in chat also. I'll wait. I'll give you 10 seconds if you are writing in chat what is chaos testing. I'll see chat. Okay then, assuming किसी को नहीं पता, then let's see.
It's introducing the faults, right, in chaos testing. You basically introduce all kinds of faults, bring down the...
You said false, like
down
you mean false or fault? Oh yeah.
Faults.
Yeah, exactly. Like that's a good explanation. So chaos is like basically like the state of confusion or disorder. Basically, you try to introduce some fault, or you try to break the system by doing some sort of random things, or like chaos मचा देना system में, basically in simple terms, ताकि you see if the system is able to handle that or not. And now let's see क्या क्या तरीके से ये चीज़ें की जा सकती है. तो लेट्स सी, कोई एग्जांपल दे सकता है कि लेट्स से आई हैव अ सिस्टम, एंड मैंने इतना लोड जनरेट कर दिया, बट हाउ डू आई सेंड दिस लोड टू माय सिस्टम? किस टाइप से हो सकता है? आई विल गिव यू वन एग्जांपल एंड देन यू कैन थिंक ऑफ अदर थिंग्स. सो एक एग्जांपल मैंने ऑलरेडी यहाँ दिया था. लेट्स से इस पॉइंट पे जो कंकरेंसी बड़ी थी, वो that was due to the push notification sent to all their users that some player was playing very well. So marketing team decided that they want to send a notification कि धोनी अच्छा खेल रहा है, अब तो जीतेंगे मैच, and then they send this notification and बहुत सारे लोग आ गए. So this is like kind of a disorder in the system. बहुत जल्दी एकदम से लोग आ जाना, that is a kind of a chaos in the system. So that's one way to introduce chaos in the system. So push notification, and imagine कितने लोगों को push notification भेजा गया था. So 13 million is the concurrent users that Hotstar handled, but actually Hotstar has like what, more than 200 million users. So push notification to, I'm not 100% sure 200 million से ज़्यादा ही है, but the amount of users registered on their platform is certainly more than 13 million. So let's say it is 100 million. So they are sending push notification to 100 million users. अब उसका कुछ परसेंट भी आते हैं, लेट्स से उसका 10-15% भी आ जाते हैं, या फिर लेट्स से 5% भी आते हैं. सो यू आर बेसिकली एडिंग 5 million यूजर्स इन दिस अमाउंट ऑफ टाइम. सो that's what chaos is. So that's one way to introduce chaos in the system. So एक तरीका क्या हो सकता है कि बहुत ज़्यादा push notification भेजें and इतना सारा ट्रैफिक आ गया, so your system must be able to handle that traffic. Now what else? Like try to think of some examples. कैसे क्या और तरीके हो सकते हैं जिससे सिस्टम में chaos आ सकता है, या like kind of fault आ सकता है,
मैच को ओपन
disorder
करे, बार-बार होम स्क्रीन पे जाए.
Like that's like very small percentage of users, but you have to think in big numbers. Like अगर 10 million users क्या कर सकते हैं? अगर 10,000 यूजर कुछ कर सकते हैं, दैट्स फाइन, यार सिस्टम कैन हैंडल दैट. लेट्स टॉक कि मेजॉरिटी ऑफ यूजर्स क्या करेंगे. बट द वे यू सेड, उसमें छोटा सा आंसर है इसका. लाइक पार्ट ऑफ द आंसर इज, if many people open the match, basically that's like called traffic. Tsunami traffic. तो अगर 5 मिलियन यूजर्स भी एकदम से ऐप खोलते हैं कंकरेंटली, सो दैट्स लाइक लॉट्स ऑफ ट्रैफिक. सो एक लाइक सुनामी आ जाना, और लाइक इट कैन, यू कैन आल्सो से डेथ वेव बेसिकली. इतने अमाउंट ऑफ यूजर्स ओपनिंग द प्लेटफॉर्म, that's a lot. So that's another way of chaos testing. What else? Some I thought so कि किसी ने अनम्यूट किया था, so speak up.
यस, सो सपोज 6 मारा है धोनी ने, और सब लोगों को फिर से एक बार वो 6 देखना है, सब लोग उसको फॉरवर्ड या फिर वो बैकवर्ड करके देख रहे हैं, तो वो भी अमाउंट ऑफ लोड हो सकता है ना.
ट्रू एंड बट दैट इज लाइक पार्ट ऑफ सुनामी ट्रैफिक. अगर बहुत ज़्यादा लोग एकदम से आ रहे हैं प्लेटफॉर्म पे, तो दैट्स काइंड ऑफ सुनामी ट्रैफिक ओनली. बट दैट्स अ गुड एग्जांपल.
Ajay,
Yep.
I'm sorry. So can you explain in English only? So I'm not
Yeah, sure.
comfortable with that.
Okay.
Yeah, thank you.
Is there anyone जो इंग्लिश में कंफर्टेबल नहीं है? सब लोग कंफर्टेबल हैं? Okay then, I'll use English then. Alright, what else? And let me check chat if somebody is writing there. Tea break के time leave. What do you mean by this? Oh, you mean like lots of people leave during tea break? Is that what you are saying? Vancy or okay, that's what you're saying. Okay, all right. Then yeah, that's also one way of chaos. That basically this part we talked about. You increase from here to here, but that's also chaos that you decrease from here to here. You go down very fast. So yes, infrastructure has to scale or descale basically, or downscale. Sorry, not descale, downscale. So that's another a way of introducing chaos. So downscaling very fast. What else? I'll give you another example. So there's also something called delayed scale up. So now this could be something like, so let's say you want to go from here to here, and let's say this is like 1 million and this is 13 million. So you want to go handling the traffic from 1 million to 13 million users. So you want to scale up infrastructure very fast. But what if infrastructure cannot be provisioned that fast? What if AWS doesn't have sufficient capacity in their regions? They don't have sufficient machines right now. They may, some more machines may be available, let's say after a minute or so. So that's delayed scale up. You thought that you would be able to scale up very fast, but what if there's no capacity? Like I'll just write here insufficient capacity. There could be multiple reasons for scale up, but insufficient capacity is like one of the reasons. So if insufficient, there is no capacity available for next 1 minute, you would be scaling up after a minute. You then only you can scale up. So that's delayed scale up. And if you don't scale, if you can only scale after 1 minute, for that 1 minute duration, your system is going to handle 30 million users, and that can break. Basically, you don't, if you don't have the infrastructure to support 30 million users, of course it will break. So that's also chaos in the system. And feel free to speak up if you think, if you have a counter argument that hey, this may be not correct, maybe this will happen, then I'm happy to discuss that as well. Cool. Let me check chat if there's anything else. Somebody is writing. Also had a chat option. Not sure what that is. All right. Then I'll tell you one more. Just one more. Increased latency. So one of the ways to do chaos testing is in industry, or what people do is that they would increase the latency randomly for any of the service. This is Netflix do this a lot. So what Netflix has or had, I don't know if they still have it, but what they had was they had microservices talking to each other. Let me draw it. Pencil. Yeah. Let's say there is one microservice which talks to second microservice. It talks to third microservice, and then it talks to another microservice. So like this is like a chain, and they also call it something like spaghetti structure or something like that. But assume like you have these 4 microservices. Response of this microservice depends on this. Its response depends on this, and so on. Now, what if this one now start responding very late. Maybe it takes more than 1 second. Now, even if no matter how fast this service is, let's say this service used to respond in less than 10 millisecond, or let's say realistically 50 millisecond. But if this service starts to respond in more than 1 second, latency of this service is also impacted, and in turn, as a cascading effect, this service's latency is also impacted. So that's the cascading that happens if you have this chain, and one of the microservice starts responding late or even goes down. That can also happen. So what they do is, and as part of chaos testing, they would randomly for a few parts of the request, they would start to increase the latency, and then they will see if this system will break, or if it is able to handle it. So that's also part of the chaos testing that Hotstar did to test if their system are tested will be able to handle it or not.
Ajay, I think I saw two more points actually.
Mhm.
One was like network failure, maybe in
Yeah,
cases of CDN or something.
yeah. Let's talk about that.
Or the other one was like bandwidth constraint, like let's say there is some
Yep. Let's talk bandwidth constraint. So let's talk about network failure. So network failure is, let's say this service wants to talk to this, but there's no you lose network. So basically, how your system will handle it, because it could happen, right? That let's say where's pencil? This much is in AWS region 1 R1, these two services, and this is in AWS region 2. Now two AWS regions are like separate physical regions which are totally separated, and they are connected by network, right? What if the network goes down between these two regions? They cannot communicate for a minute or so. Then there's network failure, and this server will not be able to communicate to this. So your system should be able to handle that as well. So as part of chaos testing, they would cut off system from each other for a few amount of duration, and then they will see if the system is able to handle that or not. Now handling doesn't mean that it should like basically always responds with 200. Handling means that if you're able to handle that scenario or not, that's all. Either you degrade gracefully, or you do what, but it should not like start throwing 500. That is wrong. So like that's what we don't want. All right, so that's network failure. And then bandwidth constraint is something similar, that if like let's say Hotstar was pushing out this much bandwidth, but what if you are restricted by bandwidth? What if your network doesn't support that? Maybe it can only handle up to 100 Gbps. Then what happens then? Then if your system is able to handle that or not, that is also part of chaos testing. Or like bandwidth is also can go up and down. Sometimes let's say like for concurrent users, something similar to bandwidth as well. Let's say you have this much bandwidth, then suddenly you have this much bandwidth, and then you have this much bandwidth. So now this is chaos in the system. Are you able to handle it or not? Is your system capable to handle these increase and decrease or not? That is also part of chaos testing. So yeah, that's about chaos testing. Any questions so far before I move on? No, all good. All right then. Let me talk just one more thing about in testing, and then we'll talk about how to this. So now, how do they send this traffic to basically servers? I'll talk in very brief. So they have these load generation machines basically, and then they have basically the internet, or the CDN. You could also say CDN. That's where a user basically request to. But in actual system, just this load generation machines, which are these machines, will be replaced by actual users. That's all, and the rest of the system pretty much stays the same. And then you have load balancer basically. Now let me remove that once for a second, and then you have your servers, your actual application servers who handle the request. Now this load balancer, right? I have only put one box just because I wanted to say something. Because of this much load, like 13 million is a big number. Only one load balancer cannot do it. Those load balancers also had to be sharded. They had multiple load balancers in front of servers. This is the amount of scale Hotstar handles. So they had even multiple load balancers to, and then they would uh, distribute the load further down to servers. And this is pretty much the uh, whole thing. How do they actually test it? They generate the load, then they introduce this chaos in this system, and then they see if the system is still able to serve the customers or not, or basically these machines. And yeah, if all is good, then basically you have successfully tested the system. So that we covered how do they test the system. Now let's talk about how do they actually scale. So let's say this much traffic comes in, you have introduced the chaos. Now how do you scale your systems? How do you increase capacity? What kind of strategies do they use? So let's talk about that. But before I move on, any questions? Let me also check chat. Somebody is writing.
I have a question. Like CDN is something that there is something I have hosted, and we are just fetching the data from that particular server or host. Is that what CDN is?
So CDN is most of the times used for static caching or something like that. But the concept of CDN is more general than that. The concept of CDN is basically you replicate, you have this origin, basically I will say origin, and then you have these CDN nodes. Now if imagine these nodes were not there, then the all the users that you have, I'll just draw like this, all the users, and imagine that the same users are basically selected. You have these users. If CDN nodes were not there, they would be directly going to origin. But if you have CDN, and then they would be redirected to CDN first, and only if CDN doesn't have data, then CDN will go here. So CDN is very much necessary to basically distribute the load and not having these many concurrent requests to the same origin set of servers. That's where the use of CDN is. Now, part of the, or one use case of CDN is to have static resources here, but you can pretty much have any resource here. It doesn't have to be like static or something. Any kind of thing that you basically serve from origin, you just push it to CDN first, and then CDN will further serve the users. I hope that answers your question. If it doesn't, then let me know.
Basically, you just do the caching.
Yes. To avoid sending the user from here to here, it basically cache the response for on or and send it to push it to all the CDN nodes, and then the CDN nodes will basically serve it just to distribute the load and not having all the load on the origin server. That's the use.
And
also to basically by distributing that load, right? They're also putting these files close to the user.
That's correct.
Because
Decrease latency.
Exactly. These are geo-distributed, right? Like, so all these nodes now, each user will probably contact the CDN that is closest to them, kind of.
Yep, that's correct. So let's say if let's talk about India only. Let's say this is in Mumbai. This origin server, AWS servers are in Mumbai, or the region is in Mumbai, and but you are in I don't know, Kashmir or somewhere in the north. Let's say in Delhi. But so if CDN nodes were not there, you would be getting data from Mumbai, all the streaming data. But if you have CDN, now CDNs will fetch the data from their Mumbai server, and they would have like much faster connection. They would have some sort of direct lines. They can get data much faster than you, and then you can get this data from CDN node, which sits in Delhi. So that decreases latency a lot. But that's a good point. If CDN distributes the load, what is the difference between CDN and load balancer? Load balancer is for your servers. CDN comes even before load balancer. So load, okay, you got the answer. Wait. Okay, Fancy got the answer, but somebody is asking. So load balancer is basically for your servers. CDN is for you. You send the request to CDN, and CDN will send to the servers, or basically first load balancer, and then load balancer will distribute the load further down to servers. Because you cannot have load balancer distributed like this edge in these edge. That's basically CDN only. If you start putting load balancers here, that's basically CDN only. Got it? Okay, cool.
Also, like the load balancer and the servers, those could also be like deployed to multiple geographical regions. Is that possible?
You mean all this much setup?
Yeah, the whole setup I'm talking about, the load balancer and the servers as well.
Yes, that's true. That's true. In fact, that happens. Like they could be set of servers who just handle the India region, and then the same setup goes for another country as well. It could be geo distributed. That's true.
Okay. So just
So,
can you simply explain like what are the differences like between the normal CDN and the servers that is serving our request?
so you mean this and this?
Yeah.
So server is basically your application server which contains the business logic. Let's say if you compute something or whatever is your business logic or business use case, these servers compute that result. Load balancer is just to distribute your request load to these set of servers. Load balancer doesn't contain the business logic. It just only handles the traffic. Servers is the one who actually compute it.
Alright.
Does that answer your question or?
Yes, and
Oh,
CDN, what's the difference between from these two and CDN?
CDN load balancer.
Yes, yes.
So CDN is actually a type of load balancer only if I talk in layman terms, because it balances the load on these servers. Whatever load the balance on the actual server and between the user is a load balancer only. CDN is, I would say, glorified term or whatever you can say, but this is like located, they have these distributed nodes. Node is like, one node is like machine or big machine or set of machines for the CDN that are distributed logically. You can have even one CDN node per state of India. So that is like to have the data that you want to serve to your user closest to the user. So that's the purpose of CDN. And then how do these CDN get the data that they are supposed to serve? They get the data from actual application servers. And to distribute the load on application servers, we have load balancer here. But CDN is also a type of load balancer only.
One thing to mention here is like CDN doesn't contain all the resources or all the responses that server is sent.
True.
CDN will only contain like which are like right time crucial, which have like some sort of time to leave TTL behind them, which are like crucial for some operation and crucial for a time being, and like they get the hugest like most load on them. So those resources they contain, but server can
True.
serve any kind of request, right? Is whatever you throw it. So that's the difference.
Yeah, let me explain that with the example. Let's say Netflix. Netflix has what, more than 5,000 movies, I guess. Let's only talk about movies, not series. But I'm sure they have more than 5,000 movies. But does that mean that on every CDN node, if there are like what, thousand of nodes across globally, they would put 5,000 movies across every CDN node? No, that's not what they do. They push only the trending content. If some show or some movie is trending in US, but another movie is trending in India, then India nodes or CDN nodes would contain those different set of movies than the US set of CDN nodes. So CDN only contain the data that is basically like trending popular, or basically what you anticipate that most of the users would be fetching. So you push that data to CDN, but whatever is not present on CDN, you CDN generally redirect that request to load balancer because load balancer has everything. That's like the source of truth basically. This is caching layer. This is source of truth. So it pushed the request back to load balancer. Load balancer push the request to servers and then they respond. Like, does that make the difference between these two clear?
Yes, thanks.
Okay, okay. But thanks me for that. Uh, how do they decide which server is closer to people and show them the stream? That's a good question. That's like how basically CDN works, but maybe that's a discussion for another day. Another day. Let's complete this part first, and at the end of the session, we can probably talk about it more. Let's move on to how do they scale actually, and let's see. All right. So before I talk about scale, or let's say let's see what the problem or the interesting thing is. And this is the actual number that I'm quoting for from Hotstar engineers. When they were adding these concurrent users in the system, it was basically 1 plus million users per minute. Can you imagine that number? More than 10 lakh users every minute added to the system until it reaches, like, let's say 13 million. Let's say this was 13 million, this was 1 million. They were adding these many million users per minute to the system. Now, that's the problem. Now, how do they scale? How do they make sure that their infrastructure scale to handle that much amount of concurrency? So, let's talk about the first approach, which, spoiler alert, they did not go with, but I'll still talk about it, which is something called auto scaling groups. If you are familiar with AWS and auto scaling groups, you already know. But if you are not, don't worry, I'll try to explain it. So auto scaling groups, let me put a different number. Say about 4.1. Yep. All right. So what is auto scaling group basically? So you say that I have these set of servers, or say set of machines. You make a group of them, and I'm just writing plus sign as in you can have as many machines as you specify. You can have like set of 200 machines or whatever. You make them, and these are machines basically of one kind. For the sake of simplicity, I will say that all of them are like one type of instance. Instances as in, like, let's say all of these machines has 36 CPU and 72 GB of RAM, and you have this bunch of machines defined, and you make a group of it. Now, auto scaling group is supposed to basically spin up or provision this group when it is required. So, how does it determine that, okay, I need to scale now? I'll talk about it first. But is there anyone who doesn't understand what auto scaling group is based on this explanation? Then I'll try to explain it in some other way. Okay, all everybody understand? So again, set of machines, and then you make a group of them, and then you say that I want to provision these set of machines to basically handle the load that is coming my way. Now, how does it decide that auto scale? The auto word is basically it automatically decides. There's no manual intervention here. The system itself determines that I need to scale now. Now, how does it determine it? Let's talk about that. So let's this is called like triggers, basically triggers to scale. Somebody wants to ask something, or there's some background noise. Please mute yourself if don't have any question. Cool. Then one type of trigger is basically traffic based. You see the amount of request that your system is currently processing, or you also see that, let's say you put a trigger. Now, these are triggers are basically designed manually. You kind of hard code it. Let's say you put a number that if this 70% or all the CPUs in a group reaches their 75% utilization of CPU, and if they are reaching more than 75% of utilization, that means that my system is now starting to getting overload and I need more capacity. So that's one kind of trigger that you can use. Or you can also look at, let's say, the amount of request that, let's say you want to say that if the total amount of request getting processed by a group, or one or group of basically one group is more than, or maybe let's say it has reached 5k request per second, that's the amount of it is processing now. Then you say that the system is about to reach its capacity. Let's start to spin up more instances so that we can handle the upcoming concurrency, basically. So these are kind of the traffic based triggers you can define, and if these metrics are reached, then auto scaling group decides to spin up another group, basically, because it sees that now I need more capacity. Okay, so is this traffic based trigger clear to everyone, or are there any questions? Cool, I think. Okay, then I'll assume that it is clear. Then second type is ladder based. Now I'll talk about ladder based a bit later, because that is basically what Hotstar used. But I want to first talk about the problems that happen with auto scaling group, and why did they not choose to go with auto scaling groups. So problems with auto scaling groups. Yeah, let's talk about it later. But I want to put it here because these are like, this is under triggers to scale. Either if it's traffic based or it is ladder based. But I'll talk about it in right here. I'll put the heading again. Don't worry. So problems with auto scaling groups is that, think about the problems. So let's say you have this much traffic coming in your way, the system will scale, but can you think of some problems? If you know, then just speak up.
Yeah, like after 85%, like it may saturate, the load may get saturated. So like the scaling up doesn't make any sense.
So you are saying you may over provision, that you thought that
Yeah.
you will have lots of capacity. I mean, sorry, lots of load more coming your way, but it
Load
actually didn't
coming.
come. Yeah, that's true. So over provisioning is one. What else? Even
What
though
was that, 5K
this
RPS?
basically request per second processed. RPS is request per second. So this is the amount of request you are processing now, and you can like kind of define the trigger that I know that if my system is processing these many requests, then it is near to getting overloaded. Like these metrics are basically manually designed. Okay, over provisioning is one. That's a good example. What else? Can anybody think of something else? Let me see chat. Okay, nobody's writing. So, all right then. Assuming, so I'll start next one. So one, I already talked about it a bit earlier, that insufficient capacity. Think of it like this. Let's say you are ordering on Zomato, and you are ordering on demand. If you are hungry, then you order. You did not see that, okay, I want to eat at night or 9 p.m., then I'll order it before. And no, you thought that I'll order it 9 p.m. only when I am hungry. So you actually order it, but at that time they did not have basic capacity to serve you. They did not have the food. That can similar thing can happen in AWS also. If you try to basically auto scale based on demand, or basically based on traffic, you don't know when the traffic will come. You just let it happen when it will happen. Then at the moment you need resources, you may AWS may not have the resources to serve you. So that can happen. So insufficient capacity can also happen the moment you say that I want to scale now. Maybe you don't have capacity. So that's another problem. Then let's talk about the third one. It could be that, so, and now this third problem is like kind of specific to AWS. I'm not sure about other cloud providers. I'm sure they also have some similar problems, but similar to what happens in AWS is basically retries and exponential. I'll write the term first and then I'll explain. Exponential back off. Basically, the what I'm trying to say here is, let's say you requested some machines. Let's say you requested 500 more machines, or 500 machines from AWS. Now AWS did not have it, let's say. Now it's not like AWS will fail, like the request will fail. No, what the AWS will do is, after 1 minute it will check. Now, do I have the capacity now? Now after 1 minute it doesn't check just after next minute. Like it's not like uniform window that it will check after each 1 minute. No, what it'll do is it will check after 1 minute, then it will try to check after 2 minutes, then 4 minutes, then 8 minutes. Like this is like exponentially it will check. So exponentially it will retry basically. And let's say let's say after 5 minutes you had the infrastructure. Let's say after 5 minutes you had the infrastructure, but after checking at fourth minute it will check at eighth minute. So what happens is, because of this retry, you don't have the capacity at the right time. So if you don't have the capacity, your existing system will have to handle the extra load. And I'll explain it with example. Let's say you are at this point. Sorry, you are at this point. Now you know that, let's say you anticipated somehow that traffic is now going to increase. You requested more resources, but AWS only gave you resources when you reached at this point. Um, this point. So for this duration, your existing system had to handle this extra load basically. if you have correctly tested your system and if it is able to handle, good. But if not, then that's a problem. And that's a problem with it. That's a problem due to auto scaling, basically, because you had this auto scaling thing set up, and it will try after a few minutes, basically. And you try to think that, hey, I'll just get the capacity whenever I need. Well, your system just broke because of that. So that's another problem with auto scaling groups. And I'll just mention one more that I know is step size, basically. So let's say it has the capacity, it can give you 500 machines, but it doesn't give you in one go. Like, it's not like, okay, take 500 machines. No, it will give you in steps. Take, like, let's say there are three basically availability zones, or three or more. Then it will give, like, I don't know, 20 machines to this, 50 machines to this. That's internal to AWS, but it happens like in steps. In steps, it will try to reach 500 after some time. So that also adds delay. Let's say the whole thing happens, or the whole thing takes 1 minute. For 1 minute of duration, your existing system with less number of machines had to handle more load. So that is also a problem with auto scaling group. Okay, so that is about auto scaling group. These are the problems due to which Hotstar chose not to go with auto scaling group. And now I'll talk about what they actually did. But before I talk about it, any questions about auto scaling group, or any counter argument if you think, hey, this is not a problem?
Uh, what do we mean by over provisioning?
Over provisioning is, let's say this metric reached, your CPU utilization reached at 75%. You have 10 machines right now. You spin up another 10 machines as part of auto scaling, but turns out it was a false alarm. Turns out that your 10 machines are able to handle the traffic, and then the traffic went down. Or let's say traffic was here, you anticipated it will go here, but it only went up to here. But you provision these many extra machines because you thought that the traffic will go like here. So this is over provisioning. You provision more than you need. Okay,
Okay.
cool.
Okay. Got it.
All right.
One thing to keep in mind with all of this is like there's the high cost behind any of this. So you have to be really careful with these decisions. That's why they
Yes, imagine, like, I'm only saying 10 machines, but imagine 1,000 of machine. If you over provision these many machines but you don't need it, you are basically losing a lot of, like, there will be a huge AWS bill, but you did not get that much business because you didn't basically use those machines, right, for business. So you'll be paying extra. So I'm only talking in small numbers, but just try to scale these numbers to big numbers, and you'll see it goes into millions, in fact. But that's a good point to mention. Oh, that's why over provisioning is an issue. AWS kind of handle it now these days with some sort of thing, but it's still a problem. Somebody has asked, does serverless function work on principle like this? Yes, that's correct. So it serverless. So if you have heard, like, Lambda, or not Lambda, uh, Cloud Run or Beanstalk, or these services which basically offer these service as a platform. You just deploy a service and then they scale it automatically in containers. Basically, they use these kind of traffic, that if one of, let's say you have you have this application container, you have this application container. If this application container reaches more than 75% CPU utilization, or handling more than these requests, then it will just spin up another serverless container, and it will try to distribute the load there from here to here. So yes, it is true that serverless functions, or serverless, basically the platform itself, also basically work on the principle of auto scaling. It scales based on some sort of triggers. Cool. I hope that answers your question. All right. I see no other question, or if I missed something, then please speak up. Otherwise, I'll move on. Let's see what they did now. Now, the whole problem is basically auto scaling. Let me explain it with an example. With, again, the food example. If you have guests coming at your home, then will you do this, that, okay, let the guest come and then I'll order the food based on how many guests I have? Well, that's one sensible way to go about it. But what if these problems happen, that you may be you think that, okay, I have 10 guests, I expect 5 more to come, but only one came. You ordered extra food. What if Zomato doesn't have the food the moment you ordered? And other things also, like let's say, at least you understand, you can relate these two problems for sure. So this is this exact same problem. What you do in such case? Well, you just order beforehand based on expected number of guests, or maybe let's say you say that, okay, these many guests are 100% sure to come. You just call them beforehand or whatever, but you expect basically, or you see that, okay, I had hosted some sort this event previously also, maybe last year. I expected 10 guests. This time I'll just say, as a conservative estimate, I'll say 15 guests. So you kind of, much before the event, you try to estimate the capacity. This is what happens in weddings also, right? They estimate that how many guests are coming, and then they have that much food already prepared, right? They don't prepare on the go and they count the heads. No, that's not what they do. So something similar they did. They basically did pre-provisioning. Basically, they pre-provision the infrastructure based on the expected amount of traffic either they had from previous events, because you see that they had hosted IPLs. They host IPL every year, right? They know that, they know their customer base, they know their traffic patterns. They can also analyze traffic patterns, and then they expect, let's say they expect that, okay, we expect 15 million users to come. Based on 15 million, they pre-provision the infrastructure much before the event, or like not like a month before or so, but like before the event. So whatever is a sensible time, they provision that. And even if there was insufficient capacity, they just talk to AWS guys, and then they say that, hey, we need these many machines. We don't need them right now, but we need them before this event. So can you please arrange them? And they'll happily arrange it for you. They'll just reserve the instances for you. Of course, you'll pay for it, but at least these problems won't occur right on the go. Your users won't face this issue. So they pre-provision the infrastructure, and that solves one issue, that there is no insufficient capacity now. Like, you have the sufficient capacity you've estimated based on your analysis. There is no retry or exponential backup happening. No, you have already have the capacity. There is no step size now. You already have the infrastructure provisioned with you. It is with you. So there is no step size concept here. The only problem that can happen is that you estimated 15 million users, but only, let's say, 7 or 8 million users came. That is the only problem you can still have with pre-provisioning, but that is based on your analysis now, how well you know your users. If you expect 15 million, but you only 7 million came, then there was something wrong either with your business marketing team or something like that. That's another issue to talk about. But over provision can still happen. But you see that what I'm trying to get, like, you solve these many problems using over provisioning, and that's where ladder based approach come in. So I'll talk about ladder based now. um, they don't do it based on traffic based, because you're provisioning the infrastructure much before the event, so you don't have traffic right now, but you do it based on ladder instead. Before I talk about ladder based or what it is, any question about pre-provisioning, or do you think that it is not better than auto scaling for the use case? Let me check chat as well. When auto scaling is happening, can this problem happen when the instance machine may not launch? Any reasons for that? Are you asking the reason for not having the instance launch correctly, or is that, like, if that's what you're asking, then yes, that while you're trying to spin up the instance, maybe the RAM crashed or the CPU crashed or something like that. Then uh, instance you were not able to get the capacity you need. So that can happen, yes. Or if I misunderstood your question, then please feel free to speak up or write in chat. All right, then let's talk about ladder based. So ladder based is basically, you define these ladders that at, let's say, 1 billion capacities, I will have I don't know, 100 machines. And now I'm only using these dummy numbers. Don't say 100 machines, but I'm only trying to give you an example. At 5 million users, I will have 200 machines. At 10 million users, I will have, I don't know, 500 machines. I don't know how, like, if it's linear or no, but you get the example. Basically, you have this set of ladders that if this much concurrency reached, then I will use these many machines. When this much concurrency is reached, I will use these many machines. Now there's also a buffer kept. Like let's say you reached 1 million. Now then you reach 2 million, then you reach 3 million, and now you know that you are about to hit 5 million mark as well very soon. So you need to keep that buffer. Like if you estimate that 100 million users for 1 million, sorry, 100 machines for 1 million users, then add a buffer as well. Add, let's say, I don't know, 30 machines for buffer. So like that key, if you are about to reach 15 million, at 3 million, let me write that number here. Let's say that you keep buffer for 2 million. That after you go from 1 million to 3 million, you have this 2 million buffer. That before you go from 3 to 5, you have extra these 30 machines to handle that extra 2 million load, unless you reach 5 million, and then you have 200 machines. I know this was like a disjoint way that maybe I explained, but if you have any questions or if you did not understand what I just said, please tell me and then I'll try to explain again. Or if you understood the concept of buffer, then it's fine. So
You are telling like so that 100 machines will handle about 3 million, or it will handle about 1 million only.
I'll
Oh,
try to
until-
say,
until-
yeah, I'm trying to say is 100 million machines will handle 1 to 3 million, anywhere from 1 to 3
Okay.
million. Now you add again 30 machines for basically going from 3 to 5, because you know that you are going to reach 5, but spinning up another 100 set of machines is going to take time, maybe 1 minute or 15 minutes, whatever. So during that amount of time, you have these 30 machines to handle the buffer load, basically going from 3 to 5. Cool. Any more questions? Similarly here as well, like you keep buffer and then you keep buffer, and you always keep this buffer for handling the load during the time when extra machines are getting provisioned. You need to handle that extra load, so you keep a buffer of machines for that extra load during that time only when extra machines are getting provisioned. Cool. Any questions in ladder based approach? And this is what Hotstar basically did. They used pre-provisioning and they went with ladder based approach. I'm not sure about the exact numbers, but this is the approach that they took. I'm just gonna say that this is what Hotstar used, and due to these problems with auto scaling, this is what they used. That pretty much marks the end of how did they scale. I'll also talk about a few more measures very quickly, what they did extra to make sure that they handle the users base correctly. But this is basically how they scaled their infrastructure, I mean. So any question in this part before I move on to this?
So as we saw earlier, we just moved from 1 million to 10 or 13 million, right? Within just 5 to 10 minutes. So this was very sudden traffic came on the system. Okay.
Yes.
So how this ladder base will handle if it will assign the machines quickly, 100 machine, 500 machines, to till the 500 machines. So it might take some time, so it might get crash, or some
Yes,
users may
that's
be
a
in
that's a good
between.
question. So
Yeah.
yeah, let me try to explain. So in auto scaling, what happened was, how it is different from auto scaling. You did not pre-provision the infrastructure. You say that when the traffic will come, then only I will provision it. And there's like provisioning is like two step. One, you get the machine, and second, you install stuff on the machine and basically spin it up. They're like, it's two-part thing. Now pre-provision is basically you get the machine, but you don't basically spin it up for use. It's not ready to use. It's going to take some time to kind of pull down the Docker images, container, spinning up containers or whatever. But there is still some amount of left. But you have the capacity. So in here, like that's the basic difference here. You don't have the capacity, no capacity, plus no. I'll for the sake of understanding or simplicity, I'll say no installation. But you get like what I'm trying to say. In here, you have the capacity but no installation. Basically, the machines are not readily available to use. They need some time to basically be available to use. But you have the capacity. So you reduce the time to get the infrastructure, and you ensure that when you request the infrastructure, you will have it. So as you asked that how will it basically solve the problem when going to 1 to 5 million. So when you want to go to 1 to 5, you need 100 machines. You can see from here, you need 100 to 200. So you need 100 extra machines, but you already have the capacity. In order scale, you did not have the capacity, but here you already have the capacity. So you have 100 set of machines with you. You just need to install. So installation time is faster than capacity, one thing. Second, during that installation happen, that's the buffer time, right? Like from, let's say it takes 1 minute, let's say, I'm just gonna say 1 minute. During this time, that's what buffer was for. While this is happening and extra machines are getting basically ready to be used, use these machines for as a buffer to handle the extra load. So that's how the ladder based approach basically solve the problem. Like, does that answer your question? Or
Yes, I understood.
cool.
So on ground level, those many threads we will create, right? Like 13 million users are watching, we will be creating 13 million threads to deliver that data, right?
Now, I won't go into that much detail because, like, I don't know how Hotstar actually do it on low level, if they use thread process or whatnot. But on a higher level, we'll talk about machines that they have 13 million. They have 30 million users to handle. They have these many machines, and inside it, whatever framework or whatever they use no, I don't know, thread based thing, process based thing, what kind of load balancer strategy they use. That's low level detail, and honestly, I'm not sure because I don't know about their internal things. Cool. Anybody still confused about pre-provisioning or ladder-based approach, or how is it different from here, or how does it solve the disadvantage of this system? Or if it's clear, then I'll move on to other measures. This part only is going to take like another 5 minutes, and then we'll end the session. Let me check chat as well if somebody has question. The serverless function, can they scale this approach correctly? I'm not sure what you mean. All right, I'll move on to other measures then. All right, so what else can they do apart from this? So first, okay, I'll ask you, what else can they do apart from this? Let's say they have scaled the system, but what else kind of smart tricks or hacks, let's call them hacks, can they do to basically either divert the traffic, distribute the traffic, reduce the traffic, or basically make sure that the systems or the critical system don't go down? What can they do? If you were to design a system in interview, what measure would you suggest that, hey, we can do this? Take a few seconds to think. I'll give you 30 seconds. I'll also see chat. Advertisement, are you saying like they will show advertisement or they'll hide advertisement? Oh, you're saying they'll show advertisement to, but how will that their users are still watching, or they are still concurrent users? It doesn't reduce the load, or uh, it doesn't reduce the load, right? The users are still watching load. Oh, you are saying that if you show ad, users will drop off? Is that what you're saying? Oh, okay. Well, now I'm not 100% sure how much is that is true. If you're watching a match, then if like what 7-second ad come up, you what close Hotstar and reopen it again after 7 seconds. I don't see that happen for majority of the users. Majority of the users will just, I don't know, see that 7-second ad, so they will not drop off. So the user base is not dropping for 7 seconds. If it was like what 5 minute break, then for sure maybe they would have closed the app. But for 7 or 8 second ad, they won't, or at least majority of the users won't do it. Based on subscription, they can show ads. Yeah, that's true. But as I said, if it's a small duration ad, it won't reduce your concurrency. Users will just bear the 7 or 8 second ad or 10-second ad, and they'll keep on watching. If it's a 5 minute or 10 minute tea break, then maybe yes, then maybe some users will drop off, or consideration amount will drop off. But for 7 or 8 second ads, maybe they will not. What else? But that was a good thing. You're thinking in the good direction. There are some things you can do to kind of divert the users for the time being. If you're seeing that your system is getting overloaded, maybe yes, you can do it. or maybe you need that, okay, I need 1 minute to provision my extra thing, or I need 1 more minute, then only my system will be able to handle this. Then maybe you can show ad for 1 minute or so. You maybe put a break, that 1 minute break or something like that. New show available in homepage. Not sure what you mean by that. All right, I'll write a few. Then I'll give you time to think, but I'll write a few. So use lots of caching. And I know this is not a new measure. CDN is also caching, and they might be using caching in lots of their internal things, but caching is one. But I'll just write it. No need to explain. Now, second thing, what they did, or at least what their engineer says that they did, basically turn off non-critical services. Now, what are non-critical? So you basically divide your services in kind of three kind of services: critical, non-critical, and something like what do I say? Graceful degradation. Yeah, let's go with that. So I'll talk about these terms in a second, but these are basically on off. These are the type of, you can divide your services based basically in three. 1 second. Three categories. So one is critical. So you are watching the match. So your video service, video streaming service is critical. That's what your users are basically paying you for, or that's what they're doing on the system currently, or at least let's say more than 90% of the users are using that. Then that's very critical. You need this to be up and running. So to basically make room for critical ones, I'll write it like this: turn off non, to make room for critical ones. So you understand what critical is. Why do you need critical? Now, what is an example of non-critical services in Hotstar? Think of some non-critical services in Hotstar. I'll start it with one example: recommendation engine or recommendation service. For like what, one or for few minutes or hours, you can maybe stop recommendation. It doesn't have to be like, okay, you always need to. If more than 90% of your user base is watching match currently, for 10% of the user, you don't need to keep suggesting them recommendation for of maybe 1 or 2 hour. You can maybe stop the service for a short duration of time. So that's one non-critical service that I can think of. What do you think that is a non-critical service? Please speak up or write in chat any way you prefer.
So, Ajay, actually, so the recommendation service kind of considered it's a microservice.
Mhm.
So, recommendation service has just few instances compared to that video streaming service. So
Mhm.
why do we need why do we need to turn off that recommendation service?
So turn off as in, like, let me explain another way. Turn off as in, there could be multiple reasons. First reason is that maybe whatever it doesn't, it's not always the case that you have only 5 or 6 servers for recommendation. What if you have more? What if you can use that capacity from recommendation engine and use that capacity in the critical service itself? So that's one reason. Another reason could be because you are using recommendation system, that means your load is coming to load balancer. So you are actually overloading load balancer. It is already overloaded, but you're adding more requests to it because your recommendation service is working. So to make room for critical one, to basically not overload your service any more than it is already is, you can shut down some non-critical services. That's why.
Okay,
Cool.
got it.
They also have a good to have feature which is like 5 minutes anyone can see for free. So sometimes when the load is too high, they like kind of turn that feature off. Like you have to be signed in and you have to have a subscription to be able to watch it. That's one measure they I have read about it like that.
Yeah,
What they did,
let's.
yeah.
I'll call it like what, free,
Free tier,
freemium, free tier or
freemium.
whatever. Premium services basically, like that is not very critical. But it's like two ways or not still. So either they can shut down, basically not offer free tier, but if let's say new users are coming up, then I'm not sure about the is there a plan in Hotstar that only if you pay for it, then only you can view match, otherwise you can only see services or not? I'm not sure about that. Anyway, let's not talk about that. All right, that's another good example. Recommendation, free tier. All right, let's move on. So these are some set of non-critical services that you can basically shut down to make room for critical ones. And then there is basically graceful degradation. For example, let's understand the term first. Graceful degradation is basically you don't shut it down, you degrade it, degrade it, or basically downscale it in a graceful manner, or shut it down in a graceful manner. As in, for example, I'll give you an example from that they did actually for payments. Let's say they have payment service, and this for the idea is that if new users come in, they first have to pay, like the whole content is behind a paywall. They have to pay for subscription, and then only then they can start watching the match. But here's the problem: what if your payment service uh, is down for now? Maybe the database in that supports payment system, RDS or whatever, it is down. Then what will you say? You will say that will you start showing that the payment was not successful, so stop right there, I won't let you in? Well, that's a bad user experience. If match is happening and you are stopping your customers or new customers basically just because your some sort of service was down, you don't want to lose those customers. They may not come back, or subset of them may not come back. You're losing business. So instead of like kind of blocking the users or making bad user experience, they do this graceful degradation in a way that they will allow, for the time being, for let's say your payment service was down for about 15 minutes, then it came back again, but for 15 minutes they will allow logged in users without paying for it. They will allow them to watch content, and after 15 minutes there could be two things here. One, you already paid, like I don't know, maybe payment was unsuccessful. So either it was you do background processing to basically whatever was successful. If you got the money in your bank as a business, then you basically make them update your users to be a paid users. Or if it was not successful, then after 15 minutes you just start showing them the paywall again, that hey, you need to subscribe now. How much business will you lose in 15 minutes? But at least you did not lose the customer. That's the basically business requirement here, that you should not be losing your customer. 15 minutes watch time is not so much about for Hotstar. So this is called graceful degradation. It can even happen like unexpectedly, that something happened, or you can have it intentionally also, that to make room for critical services you can kind of degrade some of your services for the time being, right? So that's what they did basically for yeah, that's what it is. And then let's move on to the next one. Any questions about this? I'll just mention two more other measures that I know of. Let me see chart as well. Oh, okay, all right then I'll say this: intelligent client, basically. Now, what is a client? A client is any basically machine, or let's call it a machine, or any kind of device that is using your backend. Uh, it's like client server architecture. So a client is a machine or a device that uses your backend services to basically show the output to the end user. So client could be a browser, or a mobile app, or a TV, anything could be a client. So intelligent client means, like, what is a dumb client? A dumb client is whatever user request, you just make the request to backend blindly without looking at anything, and then you get the response back. You send it back to the user and show them. That's like, let's call that a dumb client. Let's just call it a dumb client. Now, what is an intelligent client in comparison? Intelligent client understand that backend is overloaded basically. How can it understand? If it start to get many 500 errors, or maybe it start to see that the server was responding normally within 100 millisecond, but, or let's say 1 second, now it is responding in what, 5 seconds. So it understand that the client backend is getting overloaded. So maybe I should stop requesting so much content, or making many requests to the backend because it is already overloaded. Why should not overload it any more than it already is? So this is basically an intelligent client. How can it do? Basically, hide some content. Basically, hide a few ads. I don't know. Hide a few ads. Hide a few recommendations. Don't show like let's say you were refreshing recommendation every 1 minute. Don't do it every 1 minute. Do it after 5 minutes, or that you can call that, let's say, delayed request. Make request after some time. So this is what an intelligent client do. They understand the backend is overloaded, so they take measures to make sure that they don't overload the backend anymore. So delayed request is one more. What else can you think of as an intelligent client? What can you do if you were to design a mobile app or web app whose backend is overloaded? What can you do to make sure that you don't overload it anymore? Please speak up or write in chat. What can you do? Nothing. Well, there's another called something called basically client side caching. We already talked about it in one of the sessions. Client side caching. You can do client side caching to basically don't make unnecessary requests to server. Delayed requests I already talked about, that if you see that server is responding very late, you make request late now. And hide some content, that's another one, but let's stop at there. So that's about intelligent clients. And yeah, I guess let's also talk about should we talk about one more measure? Yeah, let's talk about one more measure. Basically understand the user pattern or usage pattern. Basically, how do you understand the user pattern? Basically, you see that, hey, what is the user journey basically, or let's say instead of user pattern you can also say user journey. You see that how do most of the user, let's say more than 70% of the user use your app. They open Hotstar, they go to homepage. Now immediately they have, they list that what you were previously watching, so they either start resume that watching that stuff, movie, series, whatever. So they immediately click on that, or they go to match, like the other section of the Hotstar, and they start watching the match. Or let's say 70% of the users do this only. Then you know that if 70% of your users only do this much, then you should scale 70% of system that basically handle this much stuff better than the 30% of the system. So you can understand the capacity or the limits of the system. If then I give an example before, that if 90% of the users are only watching match right now, or let's say for the next 6 hours they'll be only focusing on match, then you should scale your system 90% of that system more than the 10% of the system. So that's where this non-critical critical service also comes in. So understanding your usage pattern of your app or user journey is very important, and they took this as the measure. And yeah, these are all the measures and the scaling strategies that they use, and then they were able to serve all 13 million users. And this is not their their record is 25.3 million, and they say that they were actually ready to go until 50 million. They didn't reach it because only 25 million we just watched the match, but they were ready for 50 million, and that's a huge number. So yeah, that's about Hotstar. So I'll see if there are any questions, then I'll take that question. Otherwise, we'll stop recording. So let's see, is there something in chat, or anybody has any question about any section?
Hello,
Yes.
I have one question.
Yep.
Suppose consider requests are coming 1 million to 10 million continuously. So we will get not time to install system and all.
Sorry, come up. You said from 1 million to 30 million, it comes 1 million per minute, and then
1 million to 10 million instantly, and we will not get time to install system.
so what do you mean instantly? Like after 1 second, it will go from 1 million to 10 million. Is that what you're saying? Like I didn't like.
Yes,
Sorry.
means instantly.
Instantly, let's say right now we have 1 million, and after 1 second it becomes 10 million. Like is that what you're saying?
Yes.
Well, that won't happen. Reason is because your system will not just accept those many connections. It can only handle what it can handle. If it can handle, let's say, 10,000 connections per second, then it will only accept 10,000 connections. Post that, every other user or will just start getting 500. They'll see that not able to connect, please
or
refresh.
or
you
even
you must
some
have seen that on Netflix or Hotstar many
yeah,
times, that not able to connect.
or even some kind of loader, like you will be put into a queue and you have to wait, like there will be a loader.
Yes,
There's
yes.
no way to sidestep it.
Yep. That's what it happens. If too much current concurrency comes in, you cannot handle it. Then either you just like throw 500, say that something is wrong, please refresh, or you put them in some sort of waiting queue that I'll get to you when I get to you. Yeah, that's what happens. But that's a great question.